All right, team, welcome back for Part C. Part C asks, find the x-coordinates of all the points of inflection for the graph of f. Give a reason for your answer. Oh, those are my notes. All right, let's talk about inflection points for a second. I'm going to make a Part C. An inflection point means the graph goes from concave up to concave down. Let's take a look at, or it could also go from down to up. Forgot about that. I'm just going to make a quick graph of sine of x to illustrate this. Here's one sine wave, and then here is another sine wave. Now, I've got a couple of inflection points. I've got one right here because it goes from concave down to concave up. I've got one right here because it's going from concave up to concave down, and then another one right there, down to up. These are all the inflection points. Okay, another way to think about this is that the second derivative of x is equal to 0. That's kind of the algebraic justification. All right, so let's make another fun chart. So if f is concave up, f prime will be positive. I'm sorry, increasing. F double prime will be positive. If f is concave down, f prime will be decreasing, and f double prime will be negative. If f is increasing, f prime will be positive. If f is decreasing, f prime will be negative. So, we're looking for the inflection points. Now, it doesn't show it on the graph, but right here is where f double prime of x would be 0. That also means it's going to be the point in between where f prime is increasing and then decreasing. Okay? So, we need to find something that looks like this. We need to find where f prime does that, or f prime does this. These would both be inflection points of f. Okay? Looking for a max or a min. So let's go back to our problem. I see a couple. Here we have a minimum. Up here we have a max. And then finally another relative minimum. So we actually have 3 points. Okay? Now, the justification is different because some of them go from negative to positive and some of them go from positive to negative. I'm sorry, decreasing to increasing, increasing to decreasing. It's a slope thing. So, here's what you would say. You would say f has inflection points at x equals -1 and x equals 3 because f prime of x changes from decreasing to increasing. Got it right there. Okay. And then the second one, you would say f has, because we left one out, an inflection point at x equals 1 because f prime of x changes from increasing to decreasing. So one's decreasing to increasing, the other's increasing to decreasing. Now, for your answers, you have to get all three. You would get +1 for the answers. Then you have to have both justifications for this one. And that would be another point if you have both justifications.